Okay, hello everybody, and welcome to Chapter 7, Extending Capabilities of Computers and Mobile Devices. We're going to talk a lot about inputs and outputs. Most of this pretty basic material this week. We've had, most of us, a lot of experience already working with this material. So let's just jump in and take a look. So what is an input, right? So in computing, an input device is a piece of equipment used to provide data and control signals to an information processing system, right? We talked about the CPU in previous weeks. So this control is managing the input going into and the signals around a computer or some appliance like a server. Examples of input devices include, of course, keyboards. Everybody's got one, I think. Scanners, some of us. Digital cameras, joysticks, and microphones. There are many, many, many. Pointing devices will, for example, a mouse is a pointing device. Touch screens, pen input, motion input, voice, video, reading devices. The list is longer than that, but that's all I'm going to touch on. So let's just start with keyboards. A keyboard on the computer is an input device used to enter characters, and it can do functions. You've got all those F functions, F1, F2, F3 on the top of the keyboard. And so it's a way of inputting those into the computer system by pressing buttons, or we call them keys. It is a primary device that we have to enter text. So a keyboard typically contains keys for individual letters, numbers, special characters, as well as those special functions I mentioned. They nearly all have like a typing area, some function keys along the top, some toggle keys, some navigation keys. Sometimes there'll be a media control button and even internet control button, and of course other special keys. Now, there is the standard layout of letters, numbers, and punctuation, right? It really has not changed since the typewriter in large part. There may have been 10 changes since the typewriter, but it's known as QWERTY, QWERTY, and those are the letters along the top row, top left row, and it's called QWERTY. Those are the first 6 typing keys on the top row. It's also sometimes others are known as AZERTY, AZERTY. It's slightly different than a QWERTY keyboard. Hey, that's just FYI, fun to know about your keyboard. So, staying with the same topic, desktop computer keyboards such as 101 key US traditional keyboards, or sometimes as 104/105 Windows keyboards. These still include the alphabetic characters, punctuation symbols, numbers, a variety of key functions as we discussed. The 3 items on this screen differ somewhat in the placement of the function of the keys, the key controls, the return key, the shift key, etc. Now I wanted to mention the 104/105 key PC keyboard. That was born when we added some keys, such as the Windows key, right? Wouldn't have been needed on a typewriter. Or the menu key, noted by about 4 or so dashes from top to bottom, the menu key. When those are added, usually they're in the bottom row. That of course increase the number of keys. Okay, gaming keyboards also will have some programmable keys, right? So the gamers, they want to be hot, jiggy, right, fast, so they can customize their keyboard for the game being played. Now there are also compact keyboards that have a smaller footprint, right? Like on your Microsoft Surface, if you have one. And they're usually about 9 inches to 15 inches wide, depending on the model, than the typical keyboard, which is about 18 inches wide. That's nice. That's what I like. They also there are also mini keyboards and virtual keyboards, etc. So I did want to know, back to some more history, right? The keyboard organization, right, dates back to the time of the manual typewriters. When they were first invented, the keys were arranged actually in alphabetical order. But people typed so fast that the mechanical arms that would pop up and hit the page would get tangled up. So the keys were randomly positioned to slow down the typing, actually, which is funny because when we all took typing, at least I did, took a typing class so that I could type faster. That's hilarious. So anyhow, the keys were positioned to slow down the typing and prevent these kind of jams with those arms on the letters and other symbols. And so common letters like A, S, and E are used by the third and fourth finger of the left hand, right? Those are common letters. And that's the whole reason behind the QWERTY layout, so you could get to those common letters easily, but yet they were spread out to slow you down a little bit. Interesting. That's just interesting. Not for any exam or for this course, really. Now, moving, still with keyboards, moving on. So they're designed... some are designed to prevent awkward positions, right? So we have ergonometric keyboards, which uses ergonomy, all right? Ergonomy. And that's meant to alleviate physical issues. Ergonometric keyboards, like anything that's built ergonometrically, is made to be comfortable to the human. And so these keyboards alleviate carpal tunnel syndrome, sometimes known as CTS, or other computer-related ailments, right? So this kind of keyboard positions your hands and wrists in their natural position, which really means less straining and reaching for the mouse and the keypad and the keys, etc., right? The book actually called them RSIs, as does this slide, which is repetitive strain injuries. Now, to be honest, in my mind, and I'm not a doctor and I don't play one on TV, there's no clear evidence that ergonometric keyboards can prevent carpal tunnel syndrome or any of these other kind of repetitive stress injuries. Although these alternative keyboards really can help reduce strain on the body, right? And if you have a keyboard and you love it, don't run out, and you're not in any pain or discomfort, you don't need to upgrade, right? That's really my message. But I'm not a doctor. Consult yours. Now, we move then to pointing devices, right? This is really part of the graphical user interface, or GUI, G-U-I, GUI we call it, is a pointing device, right? Which is an input, still on inputs. It's an input interface, specifically for human interface, right? It allows us, the user, to input data into the computer, right? And so the movements of this pointing device are echoed on the screen by a pointer, or sometimes we call it a cursor, or maybe even other visual changes. Sometimes a hand pops up. So an input device is used to move the pointer or cursor around the screen. Of course, the major pointing device that most of us use is a mouse from the desktop computer, and maybe a touchpad on your laptop. Although, like me, many road warriors will bring their own mouse. Sometimes there are pointing sticks available on some laptops, and some prefer trackballs over the mouse. So the key difference between an optical mouse and a laser mouse is their illumination source. An optical mouse uses an infrared LED light to illuminate the surface. And the laser mouse is going to illuminate the surface with this laser beam, right? And then, of course, there are wireless mouses, mice. There's a wireless mouse. And that's the one I use. I will use a wireless mouse and a wireless keyboard. This eliminates clutter. I do need battery power, but it's more comfortable. I can lean back in my desk or chair and type away, or click and point and click. Okay. So staying with pointing devices, some examples include, again, I mentioned a mouse, trackballs, joysticks, touchpads, and light pens. Now a touchpad, sometimes called a trackpad, is a flat control surface used to move the cursor and perform other functions on the computer. So touchpads are commonly found on laptops, and they replace that sort of functionality of a mouse. You see a touchpad on this screen. Now a trackball is an input device used to enter motion data into computers or other devices. So it serves the same purpose as a mouse, frankly, but it's designed with a movable ball on the top which can be rolled in any direction. I do not prefer a trackball. Maybe I'm just not coordinated enough. Not sure. So then touchscreens. Touchscreens on a computer, they are a display screen that can also be an input device, and that's why you touch them, a touchscreen. And staying with the theme of this chapter so far, which are input devices. We'll get to output devices in a moment. So the touchscreens do not require a separate device for input, which is nice, right? Smartphones, your tablets, many laptops, and especially all-in-ones. We talked about an all-in-one in earlier chapters. They offer touchscreens. The screens are sensitive really to pressure. So the user interacts with the computer by touching the pictures or words on the screen. It uses this sort of gesture, which is a motion you make on a touchscreen with the tip of your finger. That's called a gesture. Some of these display devices are even multi-touch. The screens recognize multiple points of contact at the same time, which is, pretty cool. Okay. Then there's another input device is a pen. A pen input refers to the way Windows lets you interact directly with the computer, this time using a pen, right? A pen can be used for pointing and also for gestures, right? That touching. A stylus is a small metal or plastic device that uses pressure instead of ink, right? And you can even use one to capture your handwritten signature. To do this, a user writes his or her name on a signature capture pad. This is what happens at the grocery store, right? At a point of sale, a POS terminal, a checkout. I mention also a digital pen, which is slightly larger than a stylus, but it's an input device also, and it's going to capture and convert your handwriting or drawings into a digital format, which is pretty cool. I'm going to do one more, then take a quick break. There's a graphics tablet. And this is a flat surface. A graphics tablet is a flat surface on which you will draw with the stylus or pen like we just discussed. So the graphics tablet is attached to the computer and the stylus to the tablet. The tablets capture this image as data, and then it's stored as a file or a document on your computer. First it'll go into memory and then into your hard drive when you save it. So the tablet works by plugging into the computer via a USB port. Now I'm going to take a quick break there, and we'll come back with motion, voice, and video input.